Hey guys, just to recap the intro to ancient astronomy like we went over in class. You don't need to know tons of detail about each of these. One thing you may need to know is just that most ancient astronomical sites were probably calendars or possibly to predict eclipses, and most of them had some sort of alignment with the solstices. So for example, on the solstice, the sunlight would shine down the corridor here in this monument. And then like Stonehenge would be another example. So here is Stonehenge. So on the summer solstice, you had the alignment with the heel stone. So again, we didn't know the exact date of this. These were these huge rocks, which there has been an ongoing controversy about how they actually moved these. And there's also an ongoing controversy about what these stones actually mean. Most people think that it is some sort of calendar. There is alignment on the solstices. There's also alignment with stars in Orion's belt. So some form of a calendar. So again, another example of something that aligns with the solstices is the dagger. So this is a sun dagger. The background, there's these striations in the rock. The sun dagger only shows through on this on the strata back here on the summer solstice. It's in New Mexico. So much more ancient is one of the earliest inscriptions. This is from Ukraine. This is from thousands of years ago. I'm not sure the exact date of this, but I want to say it's about 20,000 years ago. And this is on a mammoth tusk, and this is probably describing astronomical events. Because remember that in ancient times, knowing the cycles of night and day, the seasonal cycles, those things would have been life and death events. So it was important for people to keep track of those things. So the Greeks were really the first to begin to take actual accounts and observations of astronomical items. So some of the first written documents were actually Greek astronomical documents, but they used mathematical, not necessarily physical models. But that's still really important because it led to our first observations of planetary motion. But these were not based on necessarily physical things. So the models were generally the first principles. These were obvious, not to be questioned, so such as geocentric. Geocentric means Earth at the center. So this is an Earth-centered system. And this idea of the perfect heavens, so such as perfect spheres, flawless surfaces. A sphere was considered the most heavenly shape. So all bodies in the heavens were considered to be spherical. And they also assumed that the Earth was not moving, so therefore everything was moving around Earth, because they did not observe parallaxes in the sky. So again, our parallax is where we see a different thing from different vantage points. So for example, left and right eye. But looking at astronomical objects, they were unable to see that. Really, if they'd have taken more detailed measurement, there was parallax. They just didn't know how to actually do this properly, because remember that everything in space has very small degrees of parallax, and they were expecting to see, like here, the Colosseum moves from left to the right eye. That's the sort of parallax they were expecting to see. Had they actually had instruments to take detailed parallactic measurements, they would have seen parallax, and we probably would have had a heliocentric universe eons before we actually did. So this idea of spheres then translated to the spherical model of the heavens. So Eudoxus, again, you don't necessarily need to know that name, was the first that really theorized this, that all of the different portions of the heavens, air quotes, existed in their own different spheres. Then Aristotle, this Greek philosopher, because remember the philosophers were some of the first astronomical experts, he then divided the universe into two parts. He had then 55 spheres, and you don't need to know those numbers, but he just expanded upon the spheres. So he said that we had this imperfect, changeable Earth. So he acknowledged that there were changes on the surface of Earth, so therefore Earth was imperfect, and in part due to the people upon the Earth, but then the heavens created by God had to be, in effect, perfect. And all of the spheres in which each astronomical item that they saw, such as the sun existed in its perfect sphere, the Earth, the moon, Mars, Mercury, Venus, Jupiter, all celestial objects would have had their own sphere. So they acknowledged essentially 55 different items. So then we had the Greeks and the Chinese. The Chinese were the first to discover rocket propulsion, so they also invented the fireworks. So this is one of their very first cannons. So this is thousands of years before Christ. Then we had the first calculation of Earth's radius, so this is about 200 BC. We're not sure exactly the time, but this is taken due to different angles of shadow that were measured from Alexandria and Syene. So these were pretty far apart, a couple hundred miles apart, and Eratosthenes went to each of these different locations and measured the difference in the shadow from each of those. So the biggest thing that they had to measure at the time was a stadia, like a stadium, and he measured it to be 5,000 stadia difference. From that, he was then able to calculate Earth's radius. So he was only about 14% off, but he was closer than anyone previous or for the next 1,000 years or so. So some later refinements, you had Hipparchus that put Earth away from the center of the perfect spheres, but this was largely ignored for about 1,500 years until the time of Copernicus. So had more people actually heeded this, again, if they had acknowledged that there were small degrees of parallactic shift, we would have had a heliocentric universe far earlier than we did. So this idea of the perfect heavens and the imperfect earth really dominated for about 1,500 years. This was the accepted model. It was blasphemous to have questioned this. But as more people started looking towards the heavens and making more physical models, there were more complicated explanations needed for some of the things that they observed, such as the apparent retrograde motion. And just like you guys did in class, we can see that in looking at Mars, we can see as it progresses from west to east, it appears to do this back-flipping motion. So Ptolemy used this concept called epicycles to explain that. So he said that each planet orbited around this deferent, which was its individual sphere, its orbit, but then it completed an epicycle as it went around it. Every planet had its own specific epicycles. And the word planet actually means wandering star, because at the time, they just assumed, all of the ancients just assumed that these planets were stars that just happened to travel much faster. So remember that these observations were taken nightly, monthly, and then year upon year to notice these differences. So we had these background of fixed stars, and then we had wandering stars. And these wandering stars appeared to have this retrograde motion, and that's where the epicycles were used to explain that. So in actuality, the reason that we see this is because Mars has an orbit that sits outside of Earth, so it is a superior planet. The planets inside the orbit of Earth are inferior planets. So as Earth is overtaking Mars within its orbit, first we see Mars here against these background stars. Then as we're perfectly aligned or in opposition with Mars, we see it here. Then as we have overtaken Mars in its orbit, we see it back here. So this is the heliocentric explanation for why we see retrograde motion. It does not, in effect, actually do that. This is apparent retrograde motion. From our perspective, that's what we see. So in an Earth-centered system, there's very simple movements. But with epicycles and with a geocentric system, there was many complicated epicycles and more epicycles that were needed, and it got really complicated. So the observations that the ancients made were that the planets moved with respect to the fixed stars, that the planets changed in brightness, that the planets changed speed and velocity, that they had retrograde motion. But this is all very difficult to describe in an Earth-centered system. But again, to question that was to question all of creation itself and to question fundamental viewpoints of existence and humanity, and this was just not accepted or done. So here is a basic geocentric model with our epicycles and their deferents. So again, the deferent is that individual orbit, and the epicycle is that motion used to explain retrograde motion. So lots of these epicycles were needed and necessary. We can see Jupiter has a lot of them. We can see that the moon actually has one epicycle there as well. And here is one of Saturn's. But Mars was the planet that was observed the most because it is the closest to Earth. And being superior to us, this is where we would see that. So Mars, it was the observation of Mars that was really used to make all of our planetary motion estimations. So Copernicus was a priest, and the last thing in the world he wanted to do was speak out against the church. He was also an avid astronomer. He took many detailed observations, and he published a book And the only thing that he could theorize that would explain all of the different motions that he saw was to place the sun at the center. So this is his model. But he did not publish this until he was on his deathbed. The last thing he wanted was to be excommunicated from the church that he supported, that he believed in, and that he worked for. So on his deathbed is when he was said to have seen the first copy of his work. He died poor and alone, and he did not get excommunicated. So he was not known at all until nearly 100 years after his death. So this was not the Copernican revolution at the time. This is very much an after the fact naming of that time period. So the heliocentric universe describes these motions of the planets, makes this very uncomplicated. So here again is the sun at the center, and this explains why we see that retrograde motion. So here's that retrograde motion of Mars against the background of the fixed stars. So prograde is when it's moving forward. Retrograde would be this period that previously epicycles used to explain, which is really when Earth is just overtaking Mars in its orbit. And this explanation just really simplified the model. So then that retrograde motion is when Earth is passing the planet. So each of these different orbital positions are of Earth. Here is Mars, and back here we can see the consequences of each of those positions and what that would mean for our viewpoint. So this then eliminated Ptolemy's epicycles. But this was not met easily. This was met with great distaste from the public. This was not accepted. Hence Galileo's inquisition and excommunication. So this was not then picked up until over 100 years after Nicholas Copernicus's death.